Welcome back to the e-learning course 0, Basics of Finance, session 1.2. In this session, we will illustrate how to value perpetual cash flow streams, known as perpetuities, as well as annuities, which pay a fixed cash flow each year for a specified number of periods. We will look at cases with growth and without growth. The learning goals of this session are that you understand how to value perpetuities and annuities and get an idea how to derive these formulas from first principles. A perpetuity is a financial concept in which a cash flow is theoretically received forever. This means the present value formula has to be used to discount an infinite stream of future cash flows. Fortunately, there is a shortcut that makes it easy to calculate present values in such a scenario. Since the perpetual cash flows are assumed to be constant, we can write the present value formula as an infinite geometric series which can be simplified to the expression below. The present value of a perpetual stream of cash flows is then C divided by R. If we assume that the infinite cash flow stream starts in period 4, we can use the present value formula to determine the present value in period 3 and discount this value back to the current day by using the 3-year discount factor. The next topic we will discuss is how to value annuities. An annuity is an asset that pays a fixed cash flow each year for a specified number of years. Examples of an annuity are equal payment house mortgages or interest rate payments on bonds. To derive a formula which can be used to value an annuity, we can use the concept of valuing a perpetuity. Suppose the perpetuity A starts its payments of $1 in year 1, which implies a present value of 1 divided by R. Perpetuity B starts its cash flow payments of $1 in year 4, which means the present value today is 1 divided by R times 1 plus R to the power of 3. The 3-year annuity is now simply the difference between perpetuity A and perpetuity B. This is what we call the annuity factor. To find the present value of an annuity with an arbitrary cash flow C, we multiply that particular cash flow with a corresponding annuity factor. Let's have a look at the following example. You're supposed to obtain $5,000 each year for the next 5 years. To determine the present value of this cash flow stream, you can simply apply the DCF approach or use a shortcut and apply the previously derived annuity formula. Using the annuity formula means you multiply the constant cash flow with the annuity factor. Assume that the discount rate is 7%. This means that the present value of the annuity is $20,501. The concept of an annuity due is very much related to the concept of an annuity discussed before. The difference is that the stream of payments starts immediately in the case of an annuity due. An annuity due is worth 1 plus R times the value of an ordinary annuity. In other words, this means that we discount each cash flow by 1 year less, and the present value is increased by the multiple 1 plus R. In the context of our previous example, we can conclude that the present value of an annuity due is $21,936.07. The next example illustrates how to use the concept of an annuity to determine annual loan payments for a bank loan. Bank loans are paid off in equal installments. Suppose that you take out a 4-year loan of $1,000. The bank requires you to repay the loan with interest evenly over the 4 years. The 4 annual payments need to have a present value of $1,000. To obtain the annual loan payment, we simply divide the $1,000 by the 4-year annuity factor. Suppose the interest rate is 10% a year. The 4-year annuity factor is then 3.17. From this, it follows that the annual loan payment is equal to 1,000 divided by 3.17, which equals $315.47. So far, we know how to value a perpetual stream of cash flows. We can modify this concept by allowing that these perpetual cash flows grow at rate g. The derivation of the corresponding present value formula is along the lines of what we have done in the context of valuing a perpetuity without growth. We use again the concept of an infinite geometric series, which allows us to write the sum of cash flows as C1 divided by R minus G. For a cash flow of $1 billion that grows at the rate of 4% every period, it follows that the present value of this growing perpetuity is $16.667 billion. The formula for a growing annuity can be derived by finding the difference between the value of two perpetuities with a constant growth rate. For that purpose, suppose that perpetuity A has an initial cash flow of 1 that grows at a constant rate g from year 1 onwards. For instance, the cash flow in year 6 is 1 plus g to the power of 5. The present value is then 1 divided by r minus g. The second perpetuity starts its cash flow payments in year 4 with a cash flow of 1 plus g to the power of 3 and growth at a constant rate g. The discounted perpetuity is then given by the following expression. The present value for a 3-year growing annuity can be computed as the difference between growing perpetuity A and growing perpetuity B. After having carefully studied session 1.2, please start with the review questions.